All right. Hello and welcome to my channel. I'm Professor L, and this is a live stream for math help. So if you need help with your math, you are welcome to come hang out with me and post your problems in the chat, and I'll just hang out and work them if I can. Happy Wednesday. Hope everyone's doing well. If you don't need help with your math, then I'm just going to be hanging out, working on my board. Right now, I'm working on systems with linear equations, and I'm working on a system with 4 variables. So 4 variables, 4 unknowns, and I'm still working on this one. Yesterday, I tried to find the inverse using Gauss-Jordan elimination, and I was not successful. So I was thinking about going ahead and continuing this method, but I've decided to scrap that and go back to just the plain Gauss-Jordan and see if I can solve it one more time. Yeah, so that's what I'm working on, and I'm just going to go ahead and get right into it. So I probably want to I'll just erase all of this. And what I'm going to do is, with the Gauss-Jordan method, traditionally, we would just take your coefficient matrix and augment that with the constants and employ the concept of the identity matrix. And so that's what we're going to do one more time here on my board. And this is a brute force method because it involves kind of creative thinking and problem solving and trying to find the best moves. So it's not exactly straightforward in that regard, because there's many different options, many different ways, different steps that you could possibly take. So, all right. So let's go ahead. That's probably good enough. Again, this is just me practicing, trying to present math and not make mistakes. So that I feel like the more I do this, the better I get. And that is the goal, is to be able to present something math related wise and not make a whole lot of mistakes. Mistakes are going to be made, but I'll try to minimize them. All right, so just start by augmenting this matrix here and being careful not to make any mistakes. And again, I'm just listing the coefficients of my variables. If there's not a coefficient, then it's typically 1. If there's no variable, then it's 0. And then we'll just double check it when I'm done. -3, 0, 8. All right, so just double check one time. We've got 3, 6, 0, -3, 3, 1, 3, -1, -4, -12, 1, -1, 1, 2, and 8, 2, -3, 0, 0, 8. Perfect. All right. So what we're going to do is we're going to perform those elementary row operations, adding 2 rows. You can swap out any 2 rows, and you can multiply any row by scalars. So those are the basic elementary row operations. We're going to perform those, and eventually we want to end up with a identity matrix over here, and then everything over here should be our solution. So we have found the solution. We found it, or I found it using calculator. However, I want to be able to do it by hand. So here we go. And what I want to do first is, well, the first thing I did yesterday was I added the row 2 and 4. I don't want to do that again. What I want to do is I'm going to add think we're going to do is, wait a second. I'm going to multiply row 3 by a positive 2. That's what I'm going to do. And then I'm going to add it to row 2. So I want to do that. Wait. Now let's go ahead and add them. Okay, so let me just pause for a second. I think I'm just going to add rows 2 and 3 together first. And if anybody is watching the video, they're welcome to post steps in the chat if they see a better option for me. I would prefer to do math with other people. So there's strength in numbers. And yeah, so let's go ahead and add rows 2 and 3 together and see what happens. And then we will replace, let's go ahead and replace row 3. Let's see how small I can write. Really try and keep these lined up here. So 3, 6, 0, negative 3, 3. Just repeating anything that is not going to get changed. So 1 and 2 is not going to get changed. We get 1, 3, negative 1, negative 4, negative 12. Adding these 2 rows and replacing row 3 now. That's going to be 2. 2, 0, negative 2, and looks like negative 4. And then we've got one more row. We've got 2, negative 3, 0, 0, 8. And I don't have enough room to write another step, so we'll just go ahead and write it here, continue. And I have to decide what I want to do next. What I really want to do is I want to make this position right here 0 next, I think. So what we're going to do is we're going to divide everything from row 1 by a 3. And the way that you do that with matrix is you just, it becomes a fraction. So you're going to multiply an entire row 1 by 1/3, and we can write that here. Let's start here and write it. Actually, let's go ahead and try here. Try to stay organized. So 3 times 1/3 is 1. 6 divided by 3 is 2. That's 0. 3 divided by 1/3 is negative 1. And 3 divided by 3 is 1. And we'll just copy these other 2 rows down. Got 1, 3, negative 1, negative 4, 12. And we have 2, 2, 0, negative 2, negative 4. And then we have 2, negative 3, 0, 0, 8. Now, if I want to make this position 0, it's a little bit easier to do that. Let's see. All right, so let's change that. So we'll say negative 1/3. So what's going to happen is all of these signs are going to change. That way, okay, go ahead and divide off. Let's do that. Let's go ahead and divide off this one at the same time by 2. And we're going to erase that row just so I can stay concise. And I didn't get to spend a lot of time on this problem. The problem is that I'm so busy that this is kind of the time I've allowed for math. So I don't get to practice and make these polished these live streams. This is really just trying to stay practical. All right, so we've got 1, 1, 0, -1, and 4 divided by 2 is -2. That way, when we add these two together, I'm going to have 0 here and I'll have 0 here. So we're going to add row 1 plus row 3, and we will replace row 1. We'll do that right here. So we've got 1 minus 1 is 0. 2 minus 1 is -1. 0 and 0 is 0. 1 minus 1 is 0. And 1 minus 2 is -3. And then we can repeat the rest of these rows. We've got 1, 3, -1, -4, 12, 1, 1, 0, -1, 2. We've got 2, -3, 0, 0, 8. All right. Good. All right, so now what I want to do. I'm going to sit and think about it for just a minute. It looks like I can add rows 1 and 3 again. If I add rows 1 and 3 again and replace row 3 this time, then I can make this position 0. So let's go ahead and do that. I'll do that here. So we're going to add, let's get that down just a little bit. Row 1 plus row 3. We're going to replace row 3 this time. So we've got 0 plus, wait, we'll go ahead and write this in here. 1 and -1. 0, 0, -3. And we've got 1, 3, -1, -4, -12. We're adding rows 1 and 3 and replacing row 3 this time. So 0 plus 1 is 1. -1 plus 1 is 0. 0, 0 is 0. 0, -1 is -1. And -3 and 2 is -5. And then we'll just copy the row 4. 2, -3, 0, 0, 8. All right. So what do we want to do now? I know I need to eventually multiply row 1 by a negative number, make it positive. I also know I need to switch it because I've already essentially solved this row. But if you recall that identity matrix, we put it in here, it's 1, 0, 0, 0. So you're just essentially having zeros, and then it's 1 down the diagonal. So here's your identity for 4 by 4. But it's not essential that I do that right in the step. I just need to do that eventually. if I can somehow make this position 0 and keep these zeros, then I can replace this with row 1, but I'm just not sure. I could add row 2 and row 3 and make this position a 0. I guess that's what we'll do. All right, so I'm going to add row, let's see. Okay, row 2 plus row 4, replace row 2. Let's see if that pays off. 0, -1, 0, 0, -3. And I've got 1 and 2 is 3. 3 and -3 is 0. And then I'll be -1. Yeah. That's a 0. So we got -1, -4. And then 8 and -12 is -4. And then we've got 1, 0, 0, -1, -5. And then we've got 2, -3, 0, 0, 8. I think we've got to, all right. So I think we can make this one 0, but I'm gonna have to add it to this, let's get this just a little bit. I'm gonna have to multiply this row by a -3 to do that for this position right here. And when I do that, I'll get 0, 0, 3, and then I'll have this one solved. So we need to do that. So we're going to multiply -3 row 1 plus row 4, and we're going to replace row 4. So we've got 0. This one's going to be a +3, 0, 0, and then that's going to be a +9. And then repeat rows 2 and 3, 3, 3, 0, -1, -4, -4, 1, 0, 0, -1, -5, and then all right, so I need to add this number to 4 now. All right, so 0 and 2 is 2. 3 and -3 is 0. And then these two are 0. And then it's 8 plus 9. 8 and 9, so that's 17. 8, 9, 17, perfect. So what I need to do now is this is my row 1 and this is my new row 2. So I'm going to swap out rows. We're going to swap out some rows here. So I'm going to list this one and then I'm going to list this one. So we'll just rearrange. And so this is going to become my new row 1, 2, 0, 0, 0, 17. This one is going to be my row 2. It's 0, 3, 0, 0, 9. And then it's a tough call. What I'm going to do next. We'll leave the row 3 alone. 1, 0, 0, -1, -5. And then this will be our new row 4, it looks like. We've got 3, 0, -1, -4, -4. All right. So essentially we have the first two solved. Actually, I should have put this one last, I think. So let's redo this one. Let's just switch those two rows out so I'm saving room. Try one more time. I'm going to list this one as row 3. So we've got 3, 0, -1, -4, -4. And then this one is going to be my row 4. 1, 0, 0, -1, -5. Okay, so what I need to do is both of these are going to have to be 0. This one and this one. So I'll start by making this first one 0 by multiplying row 4 by a -3. We're going to say -3 row 4 plus row 3, and we're going to replace that we're going to replace row, actually let's replace row 3. Do that. So we've got 2, 0, 0, 0, 17, 0, 3, 0, 0, 9, 3, 0, -1, -4, -4. And then we'll have -3, 0, 0, 3. And then 3 times 5 is 15. And 2 negatives make a positive, so we're going to be positive. All right, so now 0, 0, -1, -1, -11, or positive 11. Okay. Now we're just going to add rows 3 and 4. And I'm going to replace row 3 because I don't want to mess with these zeros. It'll add more steps. So 2, 0, 0, 17, 0, 3, 0, 0, 9. And we have 0, 0, -1, -1, and positive 11. And I've got -3, 0, 0, 3, and then 15. And again, this is good practice for me writing on the board. It's harder to write down than it is to write up. Okay. I still need to make this one um, 0. So I'm going to have to use row 1. So what I'm going to do is I'm going to divide off the 2 from row 1. So we'll multiply by the scalar 1/2. And we're going to multiply row 4 by the scalar 1/3. In doing that, we'll be able to add those two together. And so let's put it up here. So we're going to say 1/2 row 1 plus 1/3 row 4, replace row 4. And so we've got 1, 0, 0, 0. And then 17 divided by 2 is 17 halves. And then we've got 0, 3, 0, 0, 9. We've got 0, 0, -1, -1, 11. And then this one is going to be -1, 0, 0, 1, and then it'll be 5. 15 divided by 3 is 5. I now want to add row 1 and 4. So row 1 plus row 4, replace row 4 is going to give me, let's see, we'll add all these other ones up real quick. We've got 1, 0, 0, 0, 17 halves. And then go ahead and divide off the 3. We'll go ahead and say 1/3 row 2 just to kind of skip a step. 0, 1, 0, 0, 3. 9 divided by 3 is 3. And then we've got 0, 0, -1, -1, 11. And then adding rows 1 and 4, it's going to give me 0, 0, 0, 1, and 17 halves plus 5. 17 halves. Where can we put this? I want to go down here. Put it here. 17 halves plus 10 halves. 10 divided by 2 is 5. So that's going to be 27 halves. So here, 27 halves. Perfect. That's 11, so we'll keep that together. All right. So it looks like I just need to add row 3 and row 4, and we're going to make this position 0. So row 3 plus row 4, replace row 3. And so we've got 1, 0, 0, 0, 17 halves, 0, 1, 0, 0, 3. We're going to add these together and replace row 3. So that's 0, 0, -1, 0. And now I have to figure out what 11 plus 27 halves is. So that is 22 halves plus 27. And that's 49. So I've got 49 halves. You just turn it to improper fraction. 22 divided by 2 plus 27 divided by 2. Add your numerators, you get 49 over 2. Good, I think we got it solved. So we got 0, 0, 0, 1, 27 halves. And then all I got to do is multiply row 3 by scalar -1. It's going to change the sign. So we'll have, all right, so we got 1, 0, 0, 0, 17 halves. We got 0, 1, 0, 0, 3, 0, 0, +1, 0, negative 49 halves. And we've got this one, 0, 0, 0, 1, 27 halves. Perfect. And so that now we just need to make sure that these match. And I think they do. We've got 17 halves, 3, negative 49 halves, and 27 halves. Perfect. All right, and I did that in less than 30 minutes. All right, perfect. So I was able to successfully solve this using the Gauss-Jordan elimination method. So we'll go ahead and stop there. And anybody out there ever wanting to learn how to use the method, now I have a successful video out. So I'm going to go ahead and probably call that good for today. As a reminder, I am not hosting live stream tomorrow. I have a prior engagement, and as you know, you can't be in 2 places at once. So I will be back on Friday, and I hope that everyone has an amazing rest of their Wednesday. Thank you so much for watching my videos, and I will just say bye for now. I will see you next time.